a sine omega t. Okay, so uh, this is the input function for these non-homogeneous differential equations. So it can be also solved uh, by any input frequency omega. So there are many examples of the like such a periodic input function, not only sin omega t, some other functions like if we have ft in function t, then some this type of function is there. So this is also one type of periodic function, and another function is like sawtooth function called. So the technique is that any type of periodic function can be written in the terms of sine or cosine, such that uh, like any Fourier series can be written one constant a0 by 2 plus some summation from n is equal to 1 to infinity an cos n pi t upon capital T plus bn sin n pi t upon capital T, where this t is the period of the function, which is defined in some period where t is less than t to minus t. So the period will be 2t, right? So this will be our sine Fourier series of some function ft. Okay, so uh, then like if it is defined some function t from in interval minus t to t, then like f of minus t, this limit approach to something limit f of t where t tends to minus t. Okay, or we can say t greater than t, then this function is t. Similarly, if we go to this limit, then we can define little bit before this t as a limit. This function defined as a limit t tends to t and t less than t. Okay, function of t. So how can we find this a0, an and vn? Okay, so this can be defined by these a0, a n and vn. These are the Fourier coefficient called Fourier coefficient, and it is defined as a0 is equal to what, that is the interval t minus t to t f of t dt. Okay, and the an will be defined as a uh, time average, not time average, it is called time average minus t to t f of t. This an is the coefficient of cos term. Okay, so it is defined as a sorry, not dt, cos n pi t upon t.
No, no, no. In A not, not cost term. A not,
So
there
sorry,
will no.
अरे एक्चुअली मैं गलत लिख दिया, ये नीचे वाले में लिखना था, सॉरी, थैंक यू. So this will be cos n pi t upon capital T dt. Okay, and similarly this Vn can be, written as 1 by t minus t to t f of t sin n pi t upon capital T into dt. Okay, where this n can be very,
A not, what will be written?
sorry,
In what? A not.
a naught is the 1 by t
And,
minus t to t f t
and
dt.
in expression, what you taken A not by 2 or A not?
I taken a naught by 2.
Okay, okay.
So this is the bn we can write like this, and our n will vary from 1, 2, 3 till infinite. Okay, so any function ft can be written like that. So one question, like some theorem, Fourier theorem, which you can remember, like uh, some function ft which is defined in interval t2 minus t. Okay, so first point, you can say like if some discontinuity uh, at t0 point, t0 is the discontinuity of the function of ft in interval minus t to, where t0 is less than t and greater than minus t, then f of t0 how can be defined? Actually, we have to redefine this. So we can redefine this like 1 by 2 uh, f of t0 minus plus f of t0 plus. Plus and minus, like if like t0 minus will be in this side, and like if it is t0, so t0 minus will be this side and t0 plus will be this side. Okay, so this the example will come, then I will tell. Second, if we want to like some function is defined in some interval, right? uh, like minus t to t, this is the interval. Then how can we expand this towards beyond t and minus t? So for that, like if f for t is a periodic expansion of the function ft, this is the periodic expansion, then it can be defined as a f of t for t less than t and minus t. In interval it is defined as, but beyond the function we can define this is t plus 2t, like from t to minus t is 2t is the interval, time interval. Okay, so periodicity of the function, then it can be defined as a f of t. Okay, so this thing. And fourth point is uh, at capital T, uh, this is the periodic expansion of at capital T and minus t will be equal to 1 by 2 f of minus t plus and plus f of t minus. Okay, so for example, if we see, uh, we have one question, like f of t equal to t upon pi, where t is less than pi and greater than minus pi, then just sketch this function. How we will sketch, like how we will define this function. So if we want to sketch this function, so uh, we have to know beyond minus pi and after pi, or
Like then divide the interval minus 1 and 1 to 2.
yeah. So f of
By pi will have
pi minus what will be?
pi minus equal to t.
Hmm? This will be minus 1, sorry, plus 1, and
Yeah, plus 1.
f of pi minus pi plus, this will be minus 1, right?
What you written previously, if it is discontinuous for the discontinuous function.
Yeah, at pi it is discontinuous because t is always greater than minus pi and less than pi, not equal to.
Okay, okay, okay.
Okay, so if we want to find the function at pi, it should be equal to minus pi, which we write here, periodic expansion at t and minus t. This should be 1 by 2 f of minus pi plus f of pi minus, right? So it will be 0 at pi and f of minus pi. So what will be the value of then at this one? So we have to sketch, right? So the function can be sketched like uh,
You written it early for the for
periodic
Fourier
expansion.
transform.
No, for the periodic expansion. Periodic expansion means like beyond the periodicity, what will be the function? We want to
Okay.
find that. So from minus pi to pi, it is t upon pi. So the function is y equal to x, right? So if it is this is t and this is function of t, then it will be like this. Okay, because minus pi it will be minus 1 and it will be plus 1. Then after that at pi it is comes 0. Okay, so this will be the 0, this value at pi and minus pi. Then again this function starts like that. This is 3 pi, and similarly if we go to minus 3 pi, then it go like that. Okay,
Okay.
so this will be the function our which is defined by the signal of this is the function, then we can define function like that. Okay, so later we will write this function as a Fourier transform, but not now. Just like if we take another example, uh, question 2, we have to just sketch the function f of t equal to 0 for t less than 0 and f of t equal to 1 for t greater than 0. So fundamental period is minus 1 to 1. Okay, so we can say this is the step function, right? 0 to 1. So this is t and this is ft. Then it will be something like this function. So this is minus 1, this is 1. Then what will be the value of at 1? So at 1 we again find like that the half of these sum of these two. So 1 2. So this will be 1 by half. So this will be the value of at periodic point like
How,
this is
how,
2.
how you sketch this graph?
Hmm?
How you sketch this graph? I didn't understand.
Like this is t and this is ft.
For
So
t column 0, this is 1. And
yeah, at t less
with
than
the,
0, t less than 0 it will be 0. So this is the 0
yeah,
wala part.
then for 1 to between 1 to 2, it will be 0 graph it goes to 0.
Yes,
But what between 1 to it is t greater than 0, no?
t greater than 0, but the our fundamental period is given minus 1 to 1. So function of t plus t, it will be f of t, right?
Okay.
See, we consider this fundamental period minus 1 to 1.
Yeah, yeah, period minus 1 to 1.
Okay, so for that we write t plus capital T is equal to f of t. Okay, so f of t, what will be, whatever will be at t in t, after t adding this t will be again this function t. So the function will be same at which is 0, because 0 plus 1 will be f of 1, right? If we consider this periodic from this relation we will get like that.
Okay.
And at the extreme point at -1, and this value will be half from this t plus is equal to f of, sorry, minus t plus and t minus is equal to 1 by 2, whatever will be the value of t minus plus f of minus t plus. So our t is 1. Okay. So f of 1 plus 1 minus will be value 1. Okay. And minus t plus, so our -1, so -1 से थोड़ा सा ऊपर जाने पे this will be 0. Okay. So here will be 1. So f at t, or we can say f of 1 and f of -1 will be 1 by 2. Okay, that's why we show these points. So this will be 1 and this will be 0. Similarly, many functions you can just drive like that. After that, we have to solve somewhere. uh, if we want to find the Fourier series of such function, then we have to solve something like ft cos and pi x y l dx. This type of integral we have to solve. Okay, so the sort method, you can say, just for the trick, or it is called also uh, Kronecker method. Okay, so in this method we take two function like f of x and gx. Okay, so our gx will be like this and ft will be like fx. Okay, so if you integrate this by part, so you will get gx integration of fx dx minus integration of g dash x. G dash will be the differentiation of gx, and the again integration of fx dx. Okay, and then again whole integration dx. So if we consider like f1x is the integration of fx dx, then this can be written as gx f1x minus integration of g dash x, and this will be f1x. Okay, dx. Again, if you open this part, then you will get gx f1x. Here f1x is the integration of this function fx minus g dash x will be same, and integration of f1x dx, and this is again put minus, and this minus will be plus integration of g double dash x and integration of f1x g double dash x integration of f1x dx, and again dx for whole. So for the successive integral, you will just find gx f1x minus g dash x f2x plus g double dash x f3x minus g triple dash x, 3 times differentiation, plus minus again plus, sorry, f4x plus dot 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 infinite, where f1 f2 is the integration of f1, f3 is the integration of f2, and f1 is the integration of fx, like that. Okay, so this may help you while integrating the terms in this thing. Like for example, if we see minus pi to pi x cos x, sorry, nx dx, then how do you solve? You can solve directly by integrating by part, and other other than that, you can also use this form. Like if we see this is our fx, then integration of cos nx will be sin nx upon n. Okay, and if we again integrate, this will be our f1x, this is our fx, and if we integrate this one, then we will get uh, again cos integration sin x. Okay, and then sin is minus cos nx upon n square. This will be our f2x, right? So simply this is our gx. So you can solve this like gx will which will be x, and then sin nx upon n, integration from minus pi to pi, then will be minus, and differentiation of this will be 1, and again differentiation of integration of this one will be this thing. So it will be minus cos nx upon n square from minus pi to pi. Yeah. So this will be minus pi to pi. So sine n pi will be 0, sine minus n pi will be also 0. So this term will go 0, minus minus plus, and 1, cos, this will be cos n pi minus cos minus n pi. So this will again 0. Okay, so this is just the use of this canonical method. Like this is only uh, first polynomial. Like if you want like x square cos nx dx, if we integrate this in minus pi to pi, then you easily can get first x square will be same. This will be sin n x upon n minus x square differentiation 2x. Then it will be cos nx upon n square minus, then again will plus, and double integration of this one will be 2, and then cos again integration of this one sin nx upon n cube minus. Okay, so uh, again if we integrate third time, then it will be 0, right? So and all the limit is minus pi to pi, minus pi to pi, minus pi to pi. Okay, so this will be 0, because pi and minus pi both will be 0. Okay, and minus minus plus 2x cos n pi and minus cos n pi, this will be again 0. if you write this one, so sine n pi and minus sine n pi. So sine n pi upon n cube minus sine minus n pi. Hmm, cos n pi. This will not go zero. Sorry. This will be actually this x is here. So first we will put cos n pi, then minus this will be x equal to pi, and then again we will put minus pi and cos minus n pi. Okay, upon n square, and this term will be zero. Sin n pi and cos sin minus n pi. So this will come 2 upon n square. Pi will be a common, and cos n pi plus cos n pi is equal to 2. So 2 n pi will be minus 1 to the power n. So it will come 4 upon n square pi or minus 1 to the power n. So this will be the integration of this thing. Similarly, if you want uh, another function like e to the power x cos x dx, you can integrate in this way. Similar, can you solve easily?
They can.
Okay.
Also, we can write the formula in series form.
Uh,
The
Formula
given
in
formula, series form, we can written formula summation 1 to infinity. I have written that minus 1 to the power n
mm,
and n derivative of g and f n plus 1
yes,
x.
yes, yes, yes.
F formula.
You are saying about this formula, right?
Yeah,
Yeah, yeah.
that's good. That's good.
Yes, you can write. That's why I
Nice.
just write plus dot 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 inside. Okay. So I will not solve this, right? So now we will take one function f of t equal to t from t pi to minus pi, right? Now uh, we need Fourier representation of this function. So what will be the Fourier representation of this function? So we know that function is such like that this is pi, this is minus pi, and this is like that. Okay, and again like that. So uh, this is minus pi to pi. Initially we are taking t to minus t, right? So here t is pi. Okay, so our we have to find first this uh, Fourier representation. Fourier representation of any function f t is uh, a naught by 2 plus summation of a n cos n pi by t n pi by t होता है, sorry, n pi by t.
And by the way, m pi by pi, then t pi, so pi is cancelled.
Yeah,
Here t, yeah, here. Okay.
plus bn sine n pi t by t. So we have to find this a0, an, and bn. Okay, so our a0 will be uh, formula was 1 by t integration minus t to t f of t dt, right? So this will replace 1 by pi integration minus pi to pi ft is t in between minus pi to pi and dt. Okay, so it will be t square by 2 pi limit minus pi to pi. So this will give us pi square minus pi square is equal to 0. Okay, a0 will be 0. Again, if we write an, so an will be 1 upon pi minus pi to pi f of t cos and pi t upon pi. Okay, into dt. So n will go from 1 to 3 like that. So this will go 1 by pi minus pi to pi. Ft is t cos and pi. Sorry, pi will
T
cancel
pi
out
by cancel.
and t dt. So we just
Also,
solved this integration, right?
also this is odd function, so the integral will be zero. This is odd function by the integral
Yes,
property.
yes, yes.
Okay.
Odd function property also, or just we solve also this
Yeah,
zero,
yeah,
right?
we can no need to solve by
Yeah.
continuous directly.
So this will be zero,
Cannot.
and similarly we will get vn. Okay, so vn equal to 1 by pi integration minus pi to pi f of t sine and t dt. So n will be 1, 2, 3 like that. Okay, so it will be 1 upon pi minus pi to pi t sine and t dt. Okay, so this will not be 0, right? This will be even function. So we have to solve. So 1 upon pi, and this will be minus t upon n. Sine will be cos n t. Okay, this will same. Next time differentiation of t will be 1, and sine integration of sine minus cos. So minus will be plus, and again cos integration will be sine n t upon n square. Okay, minus pi to pi. So this will turn into minus t. So pi by n. So we can take this n
Right to
outside.
we can write just two times that
Mm.
because it is even function.
2 by
Uh,
n cos n pi, it will come like that.
yeah,
Uh, so you can solve this pi by n
yeah.
cos n pi.
No, no,
Uh,
no, no. So, second term is always zero.
yes,
There is
yes,
n and t.
yes.
Always zero.
Okay.
What
So
about your solve?
so how can we write? So this dn will come like that. So
Uh,
this function f
I
of,
think then the pi will cancel. There is t. Then we put then t in place
yes,
of
yes, yes,
pi.
yes, yes.
Then this will be
This will
cancelled.
come.
Yeah,
This will be
yeah.
cancelled out. So this will be minus 2 by n
Minus
cos n pi.
cos or cos and pi is equal to minus 1 to the power n.
So f of t will be minus 2
minus 2 minus 1 to the power n. We can write the cos n.
summation n is equal to 1 to infinity and minus 1 to the power n upon n sine nt, right?
Okay, fine.
Hmm. Because we write cos n pi is equal to minus 1 to the power n, right? So if we write expanding this term, so this will go like minus 2. First term will be minus sine t plus next term will be half sine 2t minus 1 by 3 sine 3t, like that. Okay. So now if we sketch the same diagram on the axis of t and f of t, okay, so how it will looks like. So this will be our period, right? Minus pi to pi. So initially it was looking like that, okay, in one period. So if we say minus pi to pi, so it comes 2 sin t, right? First term is 2 sin t. So if we write 2 sin t, so how it will go like, it will, sorry, so it will looking like that.
It goes from minus 2 to 2. It goes minus 2 to 2. Minus 2 to 2.
Huh. We are not saying like that.
And side t goes minus 1 to 1.
Huh.
Yes.
Minus 1, so 2. So this will be minus 2, it will be, sorry, this will be 2 and this will be minus 2. Okay. But if we writing only sin t, then this much discrimination, right? This
Yeah.
from here if we see, so this value to this value and here to this value to this value. Okay. If we write if we same function plot like so this will be our pi, this will be minus pi. So if we consider these two terms, okay, so this will be 2 sin t plus sin 2t. Okay, then how it will look like, sorry, minus term will come. So first if you write this one, then sin 2t will be, period will be half, right? So this will go like that, half period. Now if we subtract this curve to this curve, so it will comes like that. So you saw that in, if we consider only first term, this much deviation are coming, but when we uh, considering these two terms, then it is coming only this much deviation from this one, right? Similarly, if we consider more terms like 3 or 4 terms, so like this is t and this is f of t, then this is coming like something like this much,
it goes approx to the function.
approx to the line. Like this is
Yeah,
for
for
only three terms. If we consider 2
uh,
sine
for
t
following
minus
term.
sine 2t and plus 2y3 sine 3t. Okay, so something like that. So as much as the number of terms we consider more, the signal looks like the same as our previous signal. The in terms of sine and cosine. Okay.
Okay.
So for the if we consider some error, then we have to consider more terms of the Fourier series. That is the key points from this plot. So if we consider one more question, like our function f of t, now the function of t is again the same 0 and t, but now it is minus pi, t to 0 is 0, and from 0 to t it is pi. Okay, so this function will be like this is pi, then pi to 3 pi by 2 will be 0, then again it will 0. Okay, so this will be like that.
I just understand the concept of you are leaving that part. You are going to putting it zero
Hmm?
period. The concept of the period you are putting
See,
is
minus pi to pi, if you say minus pi to 0, it will be 0. Okay, so we sketch this line. Okay,
yeah, yeah, yeah. Left hand side we understand, and the left hand side there will
and
be
then 0 to pi it will be t. Okay,
yeah.
so t is the this point and this is ft.
I will lifting the middle pi between pi and 3 pi by 2. Writing it zero in left right hand side.
uh,
I
yes.
didn't understand that concept.
Okay, so actually what will be the value of after pi, like uh, we know the.
Yeah, after what will be value after pi?
Okay, so this is our function t, so plus 2, uh, uh,
Yeah,
this is our period t, right? Then what will be the value f of t? So
right.
we need to value at 3 pi by 2, right? So
Yeah,
t plus 2t is equal to 3 pi by 2. So from here our 2t is
where
uh,
t is pi,
hmm?
where t is pi.
See what is the periodicity
The function
from here.
repeat itself.
Yes,
Yeah, function after the period function
repeat
repeat
itself.
itself.
So
Yeah.
periodicity is 2 pi, right?
Right.
So our function f of t plus 2 pi will be f of t. So now t plus 2 pi is equal to 3 pi by 2, right? Let's say we want value at 3 pi by 2. So what will be the t? T will be 2 3 pi by 2
By 2
minus
minus 2
2
pi.
pi
Okay, okay. This will be minus pi by 2.
minus pi by 2.
Pi by 2. Okay. Then further go.
So minus pi by 2 पे वैल्यू कितना आ रहा है? 0.
0 or then next if we go 4 pi by 2, then it 2 pi, then 2 pi. Yeah, okay, okay. Okay, I understand. I understand.
Understand now?
Okay, okay.
So this is some problem from periodic function, right? So now if we consider this one, so the period is again 2 pi. In this question, the period is again 2 pi. So again we go to 0. So 1 up 2 pi is there. Then we here we have 2 upon periodicity, right? So we have 1 upon pi integration minus pi to pi f of t dt. But now our function from minus pi to pi is different, right? So we have to split this limit minus pi to 0 plus 0 to pi. Here our function is 0, minus pi to 0. Okay, so this will go 0 and 1 by pi t dt 0 to pi. So this will be t square upon 2 pi 0 to pi. So it will be pi square, so pi by 2. Okay. Uh, just in previous question, the same value when we are doing minus pi to pi, it is coming 0, but now it is coming pi by 2. Okay. So similarly, we find an equal to 1 upon pi minus pi to pi, and t is our function. Sorry, our function is 0 from 0 to pi. Uh, Minus pi to 0, it is 0 into cos n pi t upon t plus this is dt, and 0 to pi t cos n t, n t will be there, no? uh, n t dt. Okay, so this time it will come some difference. 1 upon pi will remain same. We will solve this. It will come t by n sin n t plus 1 upon n square cos n t from 0 to pi. So it will come 1 upon pi n square cos n pi minus 1, where n is equal to 1, 2, 3, dot dot dot. Similarly, we will get Vn is equal to 1 upon pi minus pi to pi f of t. We will just split minus pi to 0. This will become 0 sin nt plus 0 to pi, 0 to pi, it will be t, and this will be sin nt. Okay, so sin nt dt. So it will come 1 upon pi minus t upon n cos nt plus 1 upon n square sin nt. This will be 0 to pi. So this will come out minus 1 upon n cos n pi, where n is equal to 1, 2, 3, dot dot dot. So n pi will be again minus 1 to the power n. So it will be minus 1 upon n, and cos n pi is equal to minus 1. So minus 1 to the power n. So you can write this ft equal to pi by 4, because our function was a naught by 2 plus summation n is equal to 1 to infinite an cos n pi t by t plus bn sin n pi t but a t. So this was our function. So this will be pi by 4 because it comes pi by 2. Then plus summation n equal to 1 to infinite. This will be minus 1 to the power n minus 1 upon n n square pi cos n t minus minus 1 to the power n upon n sin n t. Okay, so you can write this in expansion like pi by 4 minus 2 upon pi cos t minus 2 upon 9 pi cos 3t from here dot dot dot. Similarly, the sine term will come plus sine t minus half sine 2t plus 1 by 3 sine 3t. Okay, so now if you plot this function, like if n equal to 5 or 10 or 20, then you will just will get something t like 1, 2, 3. This will be 0, this will be minus 1, this will be minus 2. Our function was pi minus pi to pi, right? So pi is 3.14. So it is coming somewhere here and till here. Okay. So at this point it will comes like something like that, because our initial function was something like this. Okay. So if we increase this n is equal to 10, then it will be it will become like okay. Similarly, as the number of terms will increase, this will go like that. Okay. So this is the advantage of Fourier transform. Like any function, we can write in terms of sine and cosine. It is also called trigonometric series because it is in terms of sine and cosine only. Sine and cosine is the fundamental periodic function, and any periodic function can be uh, written in terms of sine and cosine. This is the if you want to do some question, like you can solve like this: f of t is equal to sine t 0 from pi to 0 and t is 2 pi and greater than pi. Okay, or we will do in next class this series.
Okay, thank you.